Let us take the second factor, which is the effect of pressure. The pressure plays an important role, especially when we have the gaseous molecules involved as a reactant or a product. Now, pressure can be increased or decreased when the system is already at equilibrium. Now, always remember, let us take with the example that if the pressure is increased, volume will decrease, therefore the equilibrium will shift to the side which contains lesser number of moles of the gaseous substances and vice versa. It means what? If the pressure is increased, definitely we are reducing the volume of the reaction mixture of the reaction system. So once the volume is reduced, it means we are favoring to the side which contains lesser number of the moles of the gaseous substances. So the equilibrium will shift to the side which will be having lesser number of moles of the gaseous substances. And if the pressure is decreased, the volume will increase. Definitely the system will move toward the side which contains more number of moles of the gaseous substances. This can be easily explained by taking an example of the Haber's process, in which nitrogen gas, when reacted with hydrogen gas, leads to the formation of ammonia. Now in this we already know the reactant side contains 4 moles of the gaseous substances, 1 of the nitrogen, 3 of the hydrogen. Product side contains 2 moles of the ammonia. Now what happens in this case? As the pressure is increased, if the pressure is increased, the system will move as defined to the side which contains lesser number of moles of the gaseous substances. So since there are 2 moles here, 4 moles here, if pressure is increased, forward rate of reaction gets increased, system moves forward, because the product side contains lesser number of moles of the gaseous substances. And if the pressure is decreased, the rate of backward reaction gets increased. System move back, because now we are favoring the side which contains the more number of the gaseous substances. We can take one more example like this one. Hydrogen gas reacted with iodine vapors to form HI. Now in this case, since the reactant also involves 2 moles of the gaseous substances, product also involves 2 moles of the gaseous substances. Remember, therefore, in such a case, the increase and decrease of the pressure will not make any effect, any significance on the state of equilibrium. So if the delta Ng, I think you all are knowing what is this delta Ng, change in the number of moles of the gaseous substances. It is the summation of the number of moles of the product of the gases, of course, minus summation of the number of moles of the reactants, of course, gases. And if this is equal to 0, the increase or decrease of pressure has no effect on equilibrium.